All right, let's do another 6 problems and then we'll move on. Just get a little bit more practice under our belts here. For the first problem, let's do this. Y equals x cubed minus 2x plus 1 all over root x. So this is a quotient, and we're not able yet to do the derivatives of quotients, okay? So we need to simplify this a little bit. Um, if this was like, say, a plus 1 here or something, then the techniques we have currently would not work at all, because when I put that plus 1 there, I can't really simplify this now, all right? I can't write it in a different way. So fortunately, there actually isn't a plus 1 there. And the reason I can make progress on this is because I can rewrite this. Well, first of all, I'm just going to rewrite it with x to the 1/2. And then the point is I can put it underneath each of them separately. And then I can subtract those exponents, and then I will be able to find the derivative using our tools that we have at the moment. So let's keep working here. 3 minus 1/2. That's the same thing as 6 over 2 minus 1 over 2, which is 5 over 2. So this is x to the 5 over 2. Minus 2. What about this one? Well, there's really a 1 here. 1 minus 1/2 is 1/2. So this is x to the 1/2. And bring this to the top, we get x to the minus 1/2. Now we're ready to do the derivative. The derivative is going to be 5/2 x to the 5/2 minus 1, which is 3/2. And instead of writing minus 2 open bracket 1/2 x to the minus 1/2, why don't we just multiply these two right away? What is negative 2 times 1/2? Well, the is obviously negative 1, right? So minus the 1, I don't even really need to write. So I'm just going to write x. 1/2 subtract 1 is negative 1/2. Okay, I hope that part's okay. If you wanted to do it the long way, I'll just do it on scrap paper over here. Minus 2, open bracket, 1/2 x to the 1/2 minus 1. And what I'm saying here is that negative 2 times 1/2 is negative 1, right? And 1/2 minus 1 is negative 1/2. And this 1 is just unnecessary, so we get x to the negative 1/2. Sorry, this negative 1, the negative has to stay, right? But the 1 doesn't have to be written. And this expression here is what I wrote down there. So it's nice if you can do that step in one step in your head without having to bother with this. But, there's really nothing wrong with this. It just takes a little bit longer. Plus, finally, the derivative of this, negative 1/2 x to the negative 1/2 minus 1 is minus 3/2. This plus minus is kind of ugly and unnecessary, but let's clean that up on the next step. Because we have some negative exponents, we need to clean it up anyways. So 5/2 x to the 3/2 minus 1 over x to the positive half. And over here, instead of plus minus, let's just write a minus. And it's going to be 1 over 2 times x to the 3/2. And now it's all in positive exponents, so we're happy. And so that's our final answer for this one, okay? I think you get the idea. So notice we went from here to here, and this is the prepared version, right? This one is ready to go we're able to find the derivative of this, no problem. So we need to do a couple steps to get it ready to have its derivative taken, okay? This is all kind of messy. Let's go to a new sheet here. Let's take a look at this one. This one will require a little bit more work. H of x equals to x plus x inverse to the power of 3. You can say this is x to the minus 1 or x inverse. It's the same thing. Wow, power of 3. So we definitely need to work on this. We could actually do this if we knew the chain rule, which is the big powerful rule that we're kind of working towards. We could do this right now, but we don't know the chain rule yet. So we have to first multiply this out. Now, remember when we had that little square there? I kind of asked you to write them beside each other and then multiply it all out. Let's follow that same advice here by writing this out 3 times beside each other, right? And it's going to be a big expression, but we can do it. To do this, why don't we leave this first factor alone and then multiply this stuff out separately, okay? So this is the way to think about it, okay? X times x is x squared. What is x times x to the minus 1? Do you know what that is? Well, I guess there's different ways of doing it. I guess you could think of this as the power of 1 here, right? And remember, when you multiply exponents with the same bases, you just add the exponents, right? 1 times negative 1 is 0. Or sorry, 1 plus negative 1. And that gives you x to the 0, which is just 1, right? So x times x inverse is just 1. And again, x inverse times x is also 1. And what is x inverse times x inverse? Well, x to the minus 1 times x to the minus 1. We add those exponents. We get a minus 2 there, right? Minus 1 plus minus 1 is minus 2. Before we multiply this guy into there, let's combine these up, 1 plus 1. So x plus x inverse, x squared plus 2 plus x to the minus 2. So this is something you got to get used to. This is a very, very small change, right? 1 plus 1 is 2. But notice I rewrote everything, okay? A lot of students, they like scribble this out and write a 2 there. And in the end, it just looks so messy, and they wonder why they make mistakes, okay? This is why. You gotta recopy stuff out line by line. And I know it's a little bit tedious to recopy everything with such a small change. But if you want to get the right answer, I'd advise it. Now, so who cares about this FOIL stuff, okay? The way to think about it is this x here, you got to multiply that with all of 3 of these. And then this guy, that you have to also multiply them by all 3 of those. So everything in here has to be multiplied with everything in here. That's the way to think about it, okay? So let's start with x and hit x onto each 3 of these factors, okay? X times x squared is x cubed. X times 2 is 2x. What is x times x to the minus 2? Well, this is really x to the 1, so we're going to add those exponents, right? 1 plus negative 2 is negative 1. So plus x to the minus 1. So we've just accomplished multiplying x onto each 3 of these. Now let's move to this term, x to the minus 1. And also we're going to multiply it onto each of those. X to the minus 1 times x to the positive 2 is x to the power of negative 1 plus 2, which is 1. I don't have to write the 1. X inverse times 2 is 2x inverse. And x to the minus 1 times x to the minus 2. I'm going to add those exponents. Minus 1 plus minus 2 is minus 3. All right, so we've freed the brackets up now. Looks like we have some common terms here. This and this are common. And this are common. So why don't we put those together in order to get things as simplified as possible before we do the derivative. 2x plus 1x is 3x. 1 of these plus 2 of these is 3 of those. And this last term is just recopied. Okay, we're ready to go. This is now a sum. And each of the sums is a power, right? Or a constant times a power. And now we can finally start doing the derivative. So the derivative of this, 3x squared. The derivative of this is 3 times 1, which is just 3. And this one here, well, positive 3 multiplied by negative 1 is minus 3. X to the negative 1 minus 1 is negative 2. And here, there's like a 1 here, right? Phantom 1. Positive 1 times negative 3 is minus 3. X to the minus 3 minus 1 is minus 4. That's a good answer. Why don't we just rewrite it without negative exponents? 3x squared plus 3 minus 3 over x squared minus 3 over x to the 4. And there we go. So this one required a little bit more work just in the preparation, right? This was, after we got it all multiplied out, it wasn't very hard, right? The hard part is, if it's even considered hard, is just to multiply this out to cube it. Okay, so let's get a new layer here. Question 3. Don't worry, they won't all be that long. Excuse me. Number 3 here. What is number 3? Let's do this. G of u equals to root 3u minus the root of 5u. Why don't you try to pause the video and see how that goes? What you should see here is that this term here is actually just fine. We have a constant times u, right? Notice here u is not under the root sign, but over here u is under the root sign. This one here, we need to actually separate that before we do the derivative. So root 3 times u minus, let's write this as root 5 root u, okay? And now it's okay to do the derivative of, because we don't have a formula for this yet. But we do have a formula for doing this, right? This is a constant times root u. What is the derivative of root u again? I hope you've memorized that. It's 1 over 2 root u, right? And the derivative of u here, another thing you should memorize, is 1. So let's do the derivative. It's root 3 constant times the derivative of u, which is 1. So root 3 times 1 is just root 3, minus root 5, and then we multiply by the derivative of root u, which is 1 over 2 root u. And that's basically done. Why don't we just get rid of those brackets? So root 3 minus root 5 all over 2 root u. Okay? So just be careful here, because the root sign went over the whole thing, and we don't know how to do that derivative. It's a very simple change though, right? Remember this rule, right? Root of xy is root x times root y, right? You can separate out those roots. And that's what I did here in order to make it a constant times a power. Good. Number 4. What is number 4? Let's do another root one. Say v equals the 6th root of t plus 9, the root of t to the power of 5. Okay, let's, as usual, if we want to find the derivative, we should probably get rid of those roots and replace them with fractional exponents, okay? So this is t to the 1 over 6 plus 9 times t to the what? Well, there's really a little 2 hiding there. That's going to be the bottom of the fraction, and the power here is going to be the top. So it's t to the power of 5 halves. And now we can find the derivative. V prime is going to be 1/6 t. What is 1 over 6 minus 1? It's 1 over 6 minus 6 over 6. 1 minus 6 is negative 5. So we get negative 5 over 6 plus 9 times 5 halves t to the 5 halves minus 1, which is 3 halves. And let's just rewrite this first term. 1 over 6 t to the 5/6. And here, how do we multiply these fractions? Well, this 9 is really 9 over 1, right? Remember, multiplying fractions is the easiest thing because it's just top times top, bottom times bottom. 9 times 5 is 45. 1 times 2 is 2. And there we go. So there's the answer there. Let's go to a new sheet. Question 5. Question 5 is going to be this. L equals cube root x plus 1 over root x all squared. Again, we need to work on this before we do the derivative. Why don't we start off by writing it with fractional powers? So it's x to the 1/3 plus, this is 1 over x to the half. So when I bring it up to the top, it's going to be negative 1/2. And then now we need to square this out. The way we're going to do that is just write it beside each other. And then multiply all the terms out. All right, x to the 1/3 times x to the 1/3 is x to the 2/3. I get that just by adding 1/3 plus 1/3. Over here, we have to do x to the power of 1/3 plus negative 1/2. What is that? Well, let's make a common denominator of 6, okay? On this one, we're going to multiply by 2 on top and bottom. And on this one, we're going to multiply by 3. 3 times 2 is 6. 1 times 2 is 2. 2 times 3 is 6. Negative 1 times 3 is negative 3. And 2 plus negative 3 is negative 1 over 6. So this is negative 1 over 6. Plus, again, we have x to the power of negative half plus 1/3, which is we've just seen here is negative 1 over 6. And finally, with negative 1/2 plus negative 1/2 is negative 2 over 2, which is x to the negative 1. These two terms are common here, right? Why don't we combine them? So x to the 2/3 plus 2x to the minus 1 over 6 plus x to the minus 1. Now we're ready to go. Let's do the derivative. All the brackets are gone. And it's a sum, so we just do the derivative term by term. That's what the sum rule tells us, right? So power rule, bring the exponent to the front as a coefficient. Subtract 1 from the old power to get the new power. 2/3 minus 1 is negative 1/3. Here, well, I'll just write 2 opening bracket. Remember, if you have a constant times a function, you write the constant, and then you multiply by the derivative of that function afterwards. So negative 1 over 6 x to the negative 1 over 6 minus 1 is negative 1 over 6 minus 6 over 6. Excuse me. Which is negative 7 over 6. Minus, I could write the plus sign and then write minus 1, but that's just the same as minus, right? And then x to the minus 1 is minus 2. I hope you understand this part here. It's just minus 1, x to the minus 2. It's just the same as that, right? Good. We're done the derivative. Let's clean it up. Over here, let's bring that to the bottom. 1 second. Let's see here. Where were we? 2. Let's make this 2 over 1. So it's negative 2 over 6. When we simplify the fraction negative 2 over 6, divide top and bottom by 2, we get negative 1 over 3, right? And so instead of writing plus negative 1 over 3, I can just write minus 1 over 3. And why don't I bring this to the bottom while I'm at it? So 7/6. And here we have minus 1 over x squared. Let me just erase this and center it a little bit better. There we go. So there's our answer for that one. Let's try one more, and then we'll go on to something else. This last one's easy. Let's just, if you have what if you have something like this? I don't know, b of y is like ay cubed minus by squared plus c plus d y to the minus 1, okay? When you look at this, it maybe looks weird with all these letters, okay? What you need to identify is the independent variable, which is y. These a, b, and c, d, etc., those should be considered as just numbers, okay? Treat them as you would treat any number like 5 or negative 3 or whatever. So the way we don't even need to prepare this. This is all ready to go. If this was just some number, we just pull the number out front, right? And then multiply by the derivative of y cubed. And same thing here. Pull out the number, multiply by the derivative of y squared. What is the derivative of c? 0, right? And d is a number as well. Pull it out front. Using the power rule, the derivative of y to the minus 1 is minus 1 y to the minus 2. And that's it. So just be aware that you may have some questions where there's like letters in there that are different from the letter that's the independent variable. And when that happens, those letters should just be treated as numbers, okay? They're unspecified numbers, but they are just numbers. Why don't we just clean this up a little bit, get rid of the unnecessary brackets. This 0 does nothing. We can write this as d over y squared. Okay, so we've practiced finding derivatives of many functions now using our basic rules that we mentioned. But there's more rules yet, and that's going to be our topics of our next videos.